Okay, the next couple sections we talked about in class were the uniform distribution came next. And this was a very sort of straightforward distribution. You know, there was a possible range of outcomes, and all those outcomes were equally likely. And we had some formulas that went with them. And most of those questions weren't that complicated. In order to make them complicated, the textbook tended to start off as a normal distribution question and then actually ask questions from earlier sections, like it would turn it into a binomial. I decided to just not put this on the test because it seemed like there was better ways to spend our time. So this is not on the test. I think I originally said that it was going to be, but I changed my mind. So the next section that actually is on the test is the normal distribution. So remember, this is our standard bell curve we spent a lot of time talking about. And mostly there are questions where to use the normal distribution, you need to know what the mean and the standard deviation are, or the mean and the variance. And once you have the variance, you can find the standard deviation. And then we just stuck everything into Minitab. So these normal distribution questions are mostly about knowing how to do them in Minitab. So I'm just going to jump straight to an example and say, in this example, bags of rice have a mean of 5.1 pounds. So they're supposed to be 5-pound bags. And so their mean is actually 5.1 pounds, and the standard deviation is 0.2 pounds. Sometimes I might give you the variance, and then you'd have to take the square root to get the standard deviation to put into Minitab, but this time I'm just giving us the standard deviation. So find the probability that a bag of rice weighs more than 5.2 pounds. Okay, so basically what we're going to do is we're going to put this mean and this standard deviation into Minitab, and then we want to find the piece of the bell that's 5.2 or higher. So 5.2 is higher than the mean, so this is all going to be on the right side of the bell. So there's going to be a section of the right side of the bell, and we basically want to know the area of that. And we can't do the integral by hand, so we're going to rely on Minitab. Okay, flip over to Minitab, do this question over there. So it's been a while since I've done one of these. It was under graph that we did it. Okay, so lately we've been doing basic statistics to do the confidence intervals and hypothesis tests. But back with normal distribution, you could either do it with calc, probability distributions, normal. I didn't like that way, so usually I did it with graph instead so that it would draw the bell curve. So that was under graph, probability distribution plot. And I always wanted to view the probability. I wanted to see a bell with the piece shaded in that we wanted, and it would be labeled with the area, and that's what I'm really looking for. So I chose probability, view probability. We'll put in our stats here. So the bag of rice was 5.1 pounds, and standard deviation 0.2. So the mean was 5.1, standard deviation was 0.2. And my distribution is set to normal. We're doing normal distribution. Flip over to shaded area. And this normally starts as on default on probability, but probability is what we're trying to find. What we know is the other thing, the x value. So we want 5.2 and higher. So that's going to be a right tail. So everything to the right of a certain line. And the cutoff point is 5.2. So this is going to be 5.2 and higher, 5.2 because I wrote that there for the x value. And we're going to go from that line and higher because we did right tail. If we wanted something in lower, we would choose left tail. If we wanted an in between, we would do this middle version and put the two edges. The both tails thing usually came up because we knew the probability. We wanted some like the middle of the bell to like be a certain percentage, and we wanted the two tails to share the leftovers. And so both tails always splits the leftovers equally between the two tails. Okay, in this case, it's right tail though. So 5.2 and up, filling in the right tail, looks like my probability is about 31%, 0.3085. And that's it. That's the answer to the question. So that's a typical normal distribution question. One other thing that I want to say about this is relating to the central limit theorem. Basically every normal distribution day, I also labeled it with central limit theorem. Central limit theorem is just the idea that if you do an average of a whole bunch of trials, it starts to look normal. And most of the examples we did with that weren't necessarily actually averages of trials. They were just like binomials with really big numbers. And when the binomial distribution has a large number of trials, basically it's approximated by the normal. So central limit theorem, so this is going to be just like usually binomial with a large number of trials, like hundreds or thousands. So these questions didn't usually mention the central limit theorem, and you didn't really necessarily think that you were using a theorem. Pretty much all you did is you just find the mean and the standard deviation using the old formulas from whatever distribution is appropriate. So if it's a binomial type setup, you just find the mean using the old binomial formula. It would be like, how many hits do you expect? Like, what's the probability of a hit on a single trial times the number of trials? Like, if something happens a quarter of the time and you do it 1,000 times, you expect a quarter of 1,000. That's 250. So that's your mean, your expected value. And then, so expected value. And then the standard deviation, we had a formula for that for binomial also. It was the probability of a success, P, on a single trial, times the number of trials, and then there was times of 1 minus P. It was N times P times 1 minus P was the variance, and then you did the square root of that to get the standard deviation. So if it's based off of binomial, you just use those old expected value and variance standard deviation formulas for binomial to figure out your mean and your standard deviation, and then you just plug those into a normal. So then plug those into the normal distribution in Minitab. So that's not going to give you an exact answer. It is going to give you an approximation. Of course, in Minitab binomial, it can handle large numbers of trials. So you could just use the regular binomial. By hand, it's not really feasible though. Okay, so I wanted to mention central limit theorem because it did have its own chapter and it was sort of on my list of topics, but really it's just another normal distribution question with one extra step where you have to use some old formulas for binomial or whatever to find your mean and standard deviation. Okay, and then the last sections that we need to talk about are the stats sections, confidence interval, and hypothesis tests. So we'll have an example of those in a separate video.